Thank you, everyone. We are now at the closing keynote by Dr. Priyanka Sharma titled Democratizing the Use of AI. Priyanka Sharma is the Director of Software Engineering at Fujitsu Research of India and heads the Monaga Software R&D Unit and HPC AI Lab. Priyanka also represents Fujitsu as one of the founding steering committee members of Linux Foundation's Unified Acceleration Foundation. She has also held technical positions as vice chairman in several IEEE societies. She has served as AI advisor at National Defense University in India and was NVIDIA Deep Learning Ambassador for over 5 years before joining Fujitsu. With over 50 research papers published, she has mentored several solution architects and AI startup communities in strategic planning and branding. Priyanka has a passion for travel and has collaborated across the globe in the field of R&D and data analytics. She is an avid reader and enjoys writing about science, spirituality, and AI. Welcome, Dr. Priyanka Sharma.
So a very good afternoon to everyone. Good morning and good evening as well, assuming that we have viewers from all over the world for the One API Dev Summit. I'm very happy to be a part of this event and representing Fujitsu towards our mission for democratizing the use of AI. Now, before I go ahead with my presentation, I would introduce myself. So my name is Priyanka Sharma, and I basically represent Fujitsu's 2 nanometer ARM CPU project, which is Monaga. The rest of the presentation is basically focused at our goal for aligning with Unified Accelerator Foundation's mission towards democratizing AI. And at the same time, I would also like to mention what is our open source AI stack related philosophy and endeavors in reference to Fujitsu Monaga. During the talk, I would also like to share some of the insights into our contributions to Vandal enablement for ARM ecosystem, which has been like the first successful pull request in association with UXL Foundation. And along with that, I would also like to touch upon some of the other interesting software stack related contributions that we have done so far in terms of open source AI. Now, let me just move on to the next slide. So, so in this slide, basically, I have tried to, come up with a message that we all are aware of, and that is AI is pervasive in today's world. So we see, heavy use of AI in molecular dynamics and protein folding in the area of drug discovery and pharmaceuticals. We see AI being used for processing vast amount of geological and seismic data and various other applications for renewable energy domain. We also see heavy use of AI in banking and financial sectors in terms of risk modeling or portfolio optimization or real-time market forecasting, like high frequency stock forecasting and things like that. And of course, AI is the biggest enabler for the present industrial revolution. So we see a lot of AI being used for product design, failure analysis, CFD, and various other kinds of simulation that aids manufacturing industry. So with all that is happening in AI world all over and in all the domains that we can think of, we should be thankful to the contributions of HPC infrastructure in playing one of the key drivers of this AI revolution, right? And it's not just HPC; it is large volume of availability of data, as well as high-end compute, and then our capacity to develop deep neural network stack, which is large algorithms, which is making this evolution and revolution possible. But with all this progression comes the fear of generating large volumes of carbon footprint, right? And which can be and which can have a disastrous effect on the overall sustainability of planet. So while we talk about the AI revolution and we talk about different innovations that we can bring in developing algorithms and things like that, we should also be watchful of the way we are developing this technology, and that is where the task and responsibility of working towards energy efficient technology comes into picture. And with UXL Foundation and Fujitsu as a whole, not just with UXL Foundation, but Fujitsu as a company is committed to work towards sustainable digital transformation. And the project that I'm going to talk about today in detail, the Monaka 2 nanometer chip project of Fujitsu, is all about that. Okay, so the next slide basically connects the need for working towards contributing to open source AI stack, which is again one of the important mission of Monaka project. So essentially what we are focused at doing is to enable HPC workloads on open source software stack in a platform agnostic manner, right? And why essentially are we focused at doing this is because of the three factors which I have tried to mention over here, which means that when you want to re-engineer software to adapt to a different hardware platform, it can be restrictive if it's not platform agnostic. Open source and platform agnostic software design, they enable interoperability and a wider opportunity to people working with different hardware platforms and architectures to have similar stack that is used to enable AI support, right? So overall, there is a trust and transparency in the way we contribute. There is, of course, with collaboration and an innovative ecosystem from global community, and all this for increased flexibility and access of the software stack. And while we do this, it's also important to follow the standardization and security aspects of working towards this kind of development that is basically focused towards sustainable digital transformation. Now with this, I'll move on to the next slide. And this slide basically is a little about Fujitsu. So where we are, I would like to connect whatever we are doing now to our long legacy since 1990s, to our vision for many years from now, where Fujitsu has been contributing heavily towards making its own micro architectures, which has helped us in delivering the fastest supercomputers of the world, which was K Computer in 2011 and Fogacco, which was ranking first on top 500 benchmark for 4 consecutive terms. And with that comes our next generation processor that we are currently working on, and that is Monaka all about. Of course, the slide also talks about our foray and our expertise in delivering towards quantum domain, but I would like to restrict today's talk more from Monaka perspective. So with this, let me move on to the next slide. And the next slide is what is a brief introduction to what is Monaka project all about, right? So Monaka, just to quickly introduce, it is basically a 2 nanometer ARM CPU, which will basically comprise of 144 cores, 2 sockets of 144 cores, which is like 288 cores per node. And this is going to support ARM SV2, which is typically focused towards supporting AI and HPC related application ecosystem. And apart from other characteristics that you see mentioned on this slide, I would also like to mention that this chip will basically consist of ARM confidential computing architecture at both hardware level and software level. And what are we basically trying to do with this? We are trying to provide high-speed data processing platform ecosystem, which will be able to provide a blend of energy efficiency and performance, right? It will have a easy to use software stack ecosystem. And then because Monaka is basically a data centric chip, it will be supporting high security and reliability. And this is basically in execution security of the data, which is going to be supported on Monaka based data center in future. So with this brief introduction of our chip. Okay, so with this basic introduction of Monaka chip, I would now like to focus on what we are doing in the open source AI space. And that is what is represented in the slide deck. So here, as you can see, we are working towards supporting variety of cutting edge applications in the domain of healthcare and pharma, manufacturing, retail, banking and finance. And how are we doing this? We are doing this by enabling various machine learning stack for ARM, which includes our work towards the scikit-learn enablement and tuning to what we have done with thread composability, and then with OpenBlast, and our contributions to NumPy and Pandas XGBoost as well. And same way, we are working heavily towards enabling a variety of deep learning stack for Monaka, which includes fine-tuning of a variety of LLM models to enablement of 1DNN and tuning it to give a higher acceleration on ARM ecosystem. To our collaboration with OpenVINO in terms of enabling enabling it to a great extent on ARM ecosystem, and likewise we are also committed towards enabling of course these data platforms that you see, they are enabled for ARM ecosystem, but many of its features are not that tuned. So we are also focused towards tuning variety of data platforms on ARM, and along with that, our foray into ARM CCA. So I think Fujitsu is among very few, or maybe one of the first contributors of, collaborating very strongly with ARM CCA team in terms of enabling the CCA stack, ARM CCA stack. And for this, we have been collaborating with variety of internal and external organizations, to deliver our contents in the form of Dockers, containers, or in alignment with the reference applications, to supporting some of these containers on the computing workload broker architecture of Fujitsu. And the next stack that you see over here basically focuses on a variety of open source contributions that we have done in all these domains. So which includes, One API ecosystem, PyTorch, ARM software stack, and collaborations with Kubernetes and OpenBlast community. So with this preliminary understanding and our basic philosophy of contributing variety of low-level library stack to make it work and tune and accelerate it for ARM ecosystem is our mission in order to make Monaka a successful chip in future. Now, while I talk about our initiatives and our focus towards delivering to open source, I would also want the audience to know that Fujitsu has been making key contributions to OSS community for a very long time now. And that is what is reflected in the next slide that I'm trying to focus. Here, as you can see, right from our contributions to Linux kernel for mission critical server, to KVM and virtualization, to OpenStack and Kubernetes, to our initial effort towards porting 1DLN to ARM in 2021, and this is what was done for Fugaku, to the recent success behind porting of one DAL to ARM, and this has been done in the early part of 2024. And so when I talk about the one DAL chapter, in fact, we have a dedicated talk by Rakshit and the Danush from my team, where they'll be talking about what we have done with Vandal as a part of One API Dev Summit. So we have a detailed talk on that. For the contributions that we have done to Vandal, I would like to thank UXL for its support of helping us collaborate with various stakeholders in this mission. And I'm also proud to mention over here that we have been one of the founding members of Unified Accelerator Foundation, and I'm driving this initiative along with Toteguchi-san on behalf of Fujitsu. Now we have 2 new members on UXL. I should have put their logos as well on the slide. That includes G Healthcare and I think Micron. So these are 2 recent additions as part of the steering committee members of Unified Accelerator Foundation. Now, let me go ahead with our mission. So our Fujitsu Monaka's mission and UXL's mission, and how do we sync in together, right? And that is what is illustrated in the next slide that I have mentioned. So our focus in UXL is to build a multi-architecture, multi-vendor software ecosystem for all accelerators in order to unify the heterogeneous compute ecosystem around open standards, and also to build on and expand open source projects for accelerated computing. And as I mentioned before I started the talk, just when I started the talk today, is what do we get when we don't work towards developing a unified accelerator, and what do we get when we work jointly towards developing a unified accelerator. So if you focus on the right hand side of the screen, so as a part of Unified Accelerator Foundation, we work towards contributing so that we can use the same code that works optimally on all hardwares. We reduce the migration cost across to choose optimal hardware, right? So with this, now I'm moving ahead with the next slide. Okay, so now in the next slide, we would like to. The next slide is very important in terms of our contributions of porting Vandal for ARM ecosystem, and so just to explain what we have done in this enablement and tuning work, I would like to first start off with I hope everybody knows scikit-learn, right? So it is quite essential for anyone who is contributing to AI ecosystem. Learn is one of the most popular ML libraries, and Intel extension for scikit-learn, which is known as scikit-learn Intellex, and Vandal are AI accelerators that are designed to accelerate existing scikit-learn code with equivalent mathematical accuracy. Now, historically, Vandal could only be compiled on x86 architecture due to Intel's MKL, which is the math kernel library. So our team at Fujitsu basically worked towards enabling the porting of Vandal to ARM architecture, which can be said to mark a significant advancement in OSS contributions through UXL Foundation. And this effort enabled Vandal multi-architecture build with reference backend selection on ARM and optimized scikit-learn algorithms. Vandal has many critical optimized computing kernels for BLAS and APAC operations and FFT computations, which are part of Intel MKL. And to enable the functionality of Vandal on ARM architecture, Fujitsu, like the team, our team at Fujitsu replaced the MKL FPK backend, which was used on x86 with open source optimized compute kernels, that is OpenBLAS. Now, this work that we did, we actually got a performance gain of around 40x speed up across various ML algorithms, which was a significant performance gain. And our team continues to focus on optimizing AI algorithms and math kernels for ARM to ensure that our AI solutions remain at the forefront of computational efficiency in high-performance computing on ARM. So with this background of our contributions to Vandal, I would now like to move ahead with the next slide, where we are talking about our contributions to llama.cpp. Because as I mentioned initially at the beginning of our talk, our focus is to contribute to open source AI stack, and similar in lines to what we have done with Vandal enablement. The next stack that I would like to touch upon in today's talk is what our team has done for llama.cpp. So just to give a brief background, llama.cpp is basically a portable and simple inference implementation for LLM on CPUs. It is based on model binary format, which is GGUF, that is optimized for quick loading and saving of models, thereby making it highly efficient for inferencing purpose. It's already supported by AVX and Neon along with multi-threading. Now, our goal in, our team's goal was to leverage SV implementation in llama.cpp, which was missing, right? So what we did was we ported the first kernel as dot product from ARM Neon to ARM SV intrinsics for CPU efficiency, and we extended intrinsics to support multiple ISAs with ARM SV, and we also with this, we also introduced efficient parallelism to execute kernels using OpenMP library directives. And as you can see in the flow model, that we have exemplified in this diagram, with these implementations and enhancement, our team basically achieved a significant speed up in LLM inferencing on CPUs. Right, and this was also tested on Fujitsu's ARM-based A64FX processor, FX7000 server, right, and AWS Graviton 3, which is again ARM-based instance. So we have benchmarked this implementation on various other available ARM ecosystem to see its effectiveness. Right, so this was what we did with llama.cpp. And now going ahead with our next significant contributions to open source ecosystem, I would like to take you all to the next slide, which is related to our contributions to OpenBLAS OSS community routines. Okay, now with the next slide. Okay, so with this now I would like to talk about our next contribution, that is with the OpenBLAS OSS community. So OpenBLAS is one of the most important mathematical frameworks for building the OSS software stack of Monaka. And Fujitsu has worked towards optimizing math kernels in OpenBLAS and scalable multi-threading routines by utilizing the threading backends more efficiently, for example, through OpenMP, pthreads, etc. And recently, in collaboration with ARM, our team contributed towards matrix multiplication gem kernel for small matrix with SV support, and through this we achieved up to 86% CPU peak performance on ARM Graviton 3. Also, in close collaboration with math library teams in Fujitsu, Japan, we have implemented the 2D threading distribution algorithm for improving DGEM kernel performance, and through this work we have achieved performance improvement up to 10% on Graviton 3 eCPU instance. Fujitsu has also contributed significantly to improving the scalability and performance of threading backends in OpenBLAS. And these efforts include optimizing core utilization with scalable architectures, thereby improving the memory allocation by refining lock management, and also reducing contention of faster operations. So all these unit functions that you listen of, enabling and tuning that for ARM, and thereby achieving overall acceleration, is has a compounding effect on the overall performance of your application ecosystem. And additionally, Fujitsu has also introduced a new thread composability design that supports all threading backends. And all our contributions related to thread composability is already in OSS with merged pull request in OpenBlast. So we have actually implemented our framework related to thread composability in OpenBlast. So anybody who is interested to go and see what we have done, it's already merged with the main OSS link in this reference. So these contributions showcase Fujitsu's commitment to improving multi-core performance with OSS software for Monaka. Okay, so with whatever I have mentioned about what we have done with Vandal porting, with llama.cpp, and then I spoke of our contributions to the OpenBlast OSS community and what we have done with thread composability and variety of other threading frameworks. Now I would like to take you all to a very interesting addition in our software stack, and that is what we are doing in ARM confidential computing architecture space. So I will move to the next slide now, and the next slide basically showcases our vision and focus and the current collaboration in reference to our efforts towards ARM CCA for Fujitsu Monaka. So so in this slide, I would like to focus on our recent work related to ARM CCA for Fujitsu Monaka stack. Now, as I mentioned in the beginning of the presentation, CCA, which is confidential computing architecture, is intrinsic to our chip architecture, and Monaka is a data-centric chip, so CCA becomes a very important feature for security of the data which is going to be held on Monaka-based data center in future. So Fujitsu is working on various aspects of data security, and Monaka will be one of the world's first ARM-based CPU to be enabled with confidential computing ARM CCA architecture in order to support higher reliability. Now, ARM CCA protects the end user data in memory by encrypting every VM, which is virtual machine, with a different key that is generated by the processor hardware and firmware. And this is expected to be essential technology on cloud, edge and HPC environments which deals with sensitive data. In existing cloud infrastructures, although each VM is isolated from other users' VM, however, these VMs are not protected from cloud operators directly. So the focus of ARM CCA based architecture is that Fujitsu Monaka based cloud data center in future will ensure that the processor is the root of trust, and processor would encrypt each VM's memory with a different key so that user data is not accessible from cloud operators even if it's compromised due to any reason. So our team at Fujitsu is working to protect the privacy of entire AI lifecycle, which includes right from reading data, whether it is from a storage device or it is in real time, to inferencing of the data, or to some extent even the training operations related to the data, and then the post-processing of the data before it is delivered to the client, right? So Fujitsu has also joined the international consortium, which is Confidential Computing Consortium, in February 2024, which is the beginning of this year, and we have started collaboration with Linaro. Our mission here is to enhance the implementation of ARM CCA software stack through collaboration with ARM and the OSS community, and thereby focusing on standardization and implementation of common frameworks that can help our users in future. Okay, so with this, I come towards because I have primarily tried to touch our overall philosophy of contributing to open source AI stack, which is basically to support carbon neutrality, to support sustainable digital transformation, to support a global ecosystem towards AI becoming pervasive in various domains of science and technology, and to support international consortium like UXL in terms of developing open source AI stack so that it can be hardware agnostic. It can help thrive a larger volume of developer ecosystem of people who want to contribute and develop software stack that can be useful to a larger community of people, right? So so this is like the second last slide that I have, and this concludes majority of our discussion. Fujitsu Monaka is focused towards solving customer issues in future as an AI infrastructure platform that can be utilized in a wide range of domains. And as you can see, the lower bottom of this slide, I have already discussed throughout the talk, right? What are we doing in different space? On top, you can see the pink bar is our Fujitsu Monaka tuned AI software stack, and this would enable variety of other application stacks or application frameworks. And for Fujitsu, Kozuchi is one of them. So Kozuchi is our AI platform, right? And it has got support to provide a variety of AI related use cases to our customers, to our prospective customers, right? So the tuned software stack would be like a backend support to Fujitsu Kozuchi for the time being, and in future various other platforms. With this, I would go to all of today's presentation, and that is towards sharing my thankfulness on behalf of entire Fujitsu Monaka team to Japan's NIDO project, because this project that I just spoke of is based on results obtained from project JPNP 21029, which is subsidized by the New Energy and Industrial Technology Development Organization NIDO program of Japan government. And that's our commitment towards developing a technology that encourages a sustainable ecosystem, and that is contributing towards carbon neutrality. And the last slide